So we've talked about circles, we've talked about ellipses, and so now we're going to talk about hyperbolas. So let's talk about the difference between the equations of ellipses and now hyperbolas. So the similarities, they're both equal to 1. They have the a and the b values, but the difference is, here's the big difference, is the subtraction sign. Now, ellipses had a plus sign, so we didn't have to worry about which one came first. That's why the a and the b values could flip. But this time, since it's subtraction, the order matters. So the a value is always going to come first, but now the numerator is what's going to flip. So a hyperbola that opens left and right is going to have the x value first. A hyperbola that opens up and down is going to have the y value first. And then a is always going to be the first denominator value, squared, of course. So you have to be really careful, and I made note of this in your slide, that if the y value comes first, your center values are going to be backwards. We'll talk about that more in example number 2, but I wanted to point that out and make sure that you were very, very clear to watch out for that. That's going to be one of the main things that can mess us up. So let's go ahead and jump into example number 1. How do you know, looking at the equation, which direction it's going to open? Well, starts with the x value. So that means, and I'm going to make a note of this, is that it opens left and right. Now, of course, we have Desmos. We could type this into Desmos, and I encourage you to do that to check your answers, to check your center, to check your vertices, to just check your work in general. So this opens left and right. So the center value, so we have h, and h is always with x. So if you can just remember always the value with the x and then the value with the y, I think we'll be okay. So the center is going to be at flip the sign -6, flip the sign +5. So there's one of our answers because we're looking for the center. Now we have to find the vertices, and since this opens left and right, and the a value is under the x, so a is going to be 8. Take the square root of 64. We are going to add and subtract that from the x value of the center. So the x value of the center is -6. We're going to both add and subtract that a value of 8. And again, this is all in that slide. So opens left and right, you add and subtract a from the first value. Opens up and down, you add and subtract the a value from the second value. It's all there in that slide for you. So that's going to create 2 points. Oh, and it's -5. Can't forget that y value. Sorry about that. I'll make it look better when I actually write my 2 points. So -6 plus 8, -6 plus 8 is going to be a +2. So there's my first vertex, +2, comma that 5. Now -6 minus 8 is going to be -14, comma that 5. So there are our vertices. Again, check with Desmos. Highly, highly, highly recommend you do that. I'm not going to go through that. We've done enough with Desmos. I think I'm comfortable that you guys can do that on your own. So now we also have to do the slopes of the asymptotes. And I'm not going to make you graph the asymptotes or write the whole equation for the asymptote line. We're just going to do the slopes. So on the slide with the asymptote slopes, we could go back and look at that. I'll explain a little bit more about it. But for one that opens left and right, it's going to be plus or minus b over a. And I want to talk about that for just a second. I want you to think of the slope formula. The slope formula is y2 minus y1 over x2 minus x1. So it's basically the change in y over the change in x, right? We'll look up here. B is under y, A is under x. So y2 minus y1, not really, but kind of. I mean, we don't have a y2 and a y1. I'm just kind of trying to make that connection for you. So basically y over x. So now I need this b value. I didn't need it earlier, but the square root of 16 is 4. So that's going to be positive and negative of B is 4, A is 8. Of course, that can be simplified, and we do want to simplify that if we can. So the slopes of our asymptotes is positive 1/2 and negative 1/2. And that's as far as I'm going to make you go, just getting those slopes. So, of course, you won't be able to see the asymptotes in Desmos if you go in to check your work. So basically, you just need to follow the formula for these. If I was going to make you write the whole equation of the line, we could type in the equation of the line and see that. But just remember, an asymptote is going to be kind of a boundary. These hyperbolas are going to stay within those, kind of in that like the picture in the slide we saw. But all you're going to have to do is find the center, the vertices, and the slopes using those A and B values and then the H and K values.